Academy. In this video, we are going to discuss the method of undetermined coefficients for finding particular integral of a linear differential equation f of d into y equal to capital X. Okay, so in this method, the procedure is first we have to find the complementary function of the given differential equation in the usual procedure. Okay, then for finding the particular integral, we are assuming y star as a trial solution for the given problem. From that y star, we find what is dy and d square y, d cube y, etc. So depending on the problem, we find the derivatives of the trial solution and we substitute it in the given differential equation. From there, we find the constants. These constants are there, no? By substituting in the given equation, we find the constant and finally we write the general solution. So this is one of the methods to find particular integral of a linear differential equation. Already I have uploaded a video for finding the solution of a linear differential equation. I have given the link in the description box. If you want, you can go through it. Okay, right. Now in this method, depending on the nature of the right hand side, capital X, we have to take the trial solution. Here I have given 6 different cases for which the trial solutions are assumed. The first one is if the right hand side is of the form x power n, any integral powers of x, or linear combination. Either it may be simply x power n or its linear combination, that is combination of one or two terms like this a0, a1x, a2x square plus etc. Okay, in that case the trial solution is a0 plus a1x plus a2x square plus etc. an x power n. So here look at the highest power of x till that term we have to write, that is starting from the constant term, x square term plus etc. up to the coefficient, up to the power for which you have the highest term here. Okay, so this is the trial solution when you have right hand side as either x power n or a linear combination of x power n. Okay, the another one is right hand side, when the right hand side is of the form e power alpha x. Simply no other terms are there. Simply if it is e power alpha x, the trial solution is a e power alpha x. That's all. Okay, and then the third case is when the right hand side is of the form x power n e power alpha x, or that is e power alpha x with either x power n or linear combination of x power n, e power alpha x into a0 plus a1x plus etc. an x power n. So for both these cases, the trial solution will be like put e power alpha x, and then for x power n what did we write? a0 plus a1x plus a2x square plus etc. No, so write that up to the highest power of x appearing in the right hand side. Okay, so this is when it is of the form x power n into e power alpha x or e power alpha x into linear combination of powers of x. Then the fourth case is the right hand side is of the form sin alpha x or cos alpha x, that is p, q's are constants. Okay, they doesn't mean any other thing, they are just constants. So when the right hand side is of the form sin alpha x or cos alpha x or any linear combination of the sin and cos. Okay, so any linear combination of sines and cos, the trial solution is simply a sin alpha x plus b cos alpha x. So if you have only sine term, the trial solution will be a sin alpha x plus b cos alpha x. Or if you have simply q cos alpha x, then also the trial solution is what? A sin alpha x plus b cos alpha x. Even if you have the linear combination of the two functions, then also the trivial solution is what? Trial solution is a sin alpha x plus b cos alpha x. Right. Then next one is combination of e power alpha x with either sine or cos or combination of both. Okay, either e power alpha x sin beta x, e power alpha x cos beta x, or this may be any linear combination. Need not be simply sin beta plus cos beta. Any number may appear here. Okay, so any linear combination of sine and cosine function. In that case, e power alpha x into a cos beta x plus b sin beta x. Then the final one is combination of x power n with sin alpha x or x power n with cos alpha x or cos alpha x with linear combination of x, sin alpha x with linear combination of x. In all these four cases, simply the solution is sin alpha x into a0 plus a1x plus etc. an x power n plus cos alpha x into. So combination of these two should come. So these are the 6 different cases for assuming the trial solution. So once you assume the trial solution y star here, you find its derivatives. Okay, find the derivatives and substitute the derivatives in the given differential equation so that we can find the constants a0, a1, a2 are constants. No, we can find their values and we can write the general solution. Okay. So we will see a problem based on this one. Okay, solve d square y by dx square plus 2 dy by dx plus 4y equal to 111 e power 2x cos 3x. What is the first step? You have to find the complementary function. So for finding the complementary function, you have to take only the left hand side of the equation, equate the right hand side equal to 0. So d square y by dx square plus 2 dy by dx plus 4y equal to 0. Now replace d by m. So the auxiliary equation is m square plus 2m plus 4 equal to 0. Now we cannot factorize this equation. So I am going to make use of this formula. So when you have ax square plus bx plus c equal to 0, the solution of this quadratic equation are given by minus b plus or minus root of b square minus 4ac by 2a. So m equal to, here a is 1, b is 2 and c is 4. Okay, so minus 2 plus or minus root of 4 minus 4 into 1 into 4 by 2. So the roots are given by minus 2 plus or minus root of minus 12 by 2. So here it is root 12, no. So 12 means what? 2 root 3. So since we have negative sign here, the roots are imaginary. Minus 2 plus or minus I 2 root 3 by 2. Throughout cancel this 2. So we get the roots are minus 1 plus or minus I root 3. Okay. The roots are complex conjugates with real part equal to minus 1 and imaginary part equal to root 3. When you have complex conjugates as the roots, the complementary function is given by e power alpha x into a cos beta x plus b sin beta x. So here alpha equal to minus 1 real part and beta equal to root 3. So the complementary function is e power minus x into a cos root 3x plus b sin root 3x. That's all. Next we have to find the particular integral. So for finding the particular integral only, we are using this method of undetermined coefficients. So for that we have to look at the right hand side. The right hand side is combination of e power alpha x into cos beta x. Okay. So this is the right hand side. So what is the trial solution? Since e power 2x is there, e power 2x must be there. Whenever you have sine or cos function here, you have to take a1 cos 3x plus a2 sin 3x. So this is the trial solution. From this trial solution, I am finding dy by dx. That is first derivative I am finding and then second derivative I am finding and then I am substituting all these values in the given equation. So here while differentiating you have to follow product rule because both are functions of x, no. So first you keep e power 2x as it is, differentiate this value and then plus keep this value as it is and differentiate what? E power 2x. So I have find out what are the values of differentiation of y star and d square of y star. So after finding and simplifying all these values, I am substituting all these values in the given differential equation. So I am skipping the simplification parts here. So this is the value of dy star. Okay, you check the value of dy star, that is first derivative of y star, and this is the value of the second derivative of y star. So only mere simplification part only I am skipping here. So after doing all the simplifications, I am substituting the values in the given equation. Okay, so this is the given equation, equate it to 111 e power 2x cos 3x. So both on left and right hand side, e power 2x is a common factor which we can cancel. Then after that, in the left hand side, you separate the terms containing cos 3x and sin 3x separately and then equate the coefficients. Here on the right hand side, you are having only what? Cos 3x. Cos 3x coefficient is 111. There is no sin 3x. So here equate the coefficient of cos 3x to 111 and equate the coefficient of sin 3x to 0. Okay, when you equate it, I am getting it as a1 equal to 1 and a2 equal to 6. Okay, so what is the trial solution? Y star is equal to e power 2x into a1 cos 3x, that is 1 cos 3x plus 6 sin 3x. So this is the particular integral, and finally the general solution is complementary function plus particular integral. So that's all. So we find out the particular integral for this problem by using the method of undetermined coefficients. See, the method is applied for finding the particular integral. sometimes while finding the particular integral, we have capital X, that is the right hand side is there, no? This right hand side function may coincide with the complementary function. In that case, there will be a slight change in the trial solution. So, two different cases arise. I have given them in a table like this. So, here see this nature of the term in X, which is also a term of complementary function. That is, on the right hand side of the given equation, you will be having some capital X, no? One or all the terms in the right hand side may appear in the complementary function also. Okay, so that term here. Then next one is, if u is the term which is repeating both in complementary function and also in the right hand side, then what you have to do? Look at the factor of f of d. F of d is there, no? You will be factorizing that f of d in the complementary function, no? Look at the factor of f of d, okay, in which this u is appearing. If it is of degree m, it may be a linear power or second power, third power, etc. No, look at the power. If it is of mth power, then in the trial solution you have to include this. This is mth power, no? So x power m into, this is the term repeating in complementary function and the what, right hand side. So x power m into u and all its derivatives should appear in the trial solution. Okay, so this is something different from the previous problem which we have done. Okay, suppose not only this u, x power r u is there in the right hand side. Capital X is there, no? U is a repeating factor in complementary function and right hand side, but in the right hand side u is not appearing as a single function. It is appearing like x power r into u. In that case, what you have to do is again look at the factor of the what, f of d. If it is mth power there, then you have to include what, x power r plus m into u. Okay, here it is simply x power m into u. When this u appears alone in right hand side, when this u is appearing like x power r into u in the right hand side, you have to include which factor, x power r plus m into u and all its derivatives in the trial solution. Okay, we'll see one problem for this. See, this is a problem. D square minus 4d plus 4 into y equal to what? X cube into e power 2x. Right? Now, for finding the complementary function, take the left hand side. D square minus 4d plus 4 equal to 0. Let d equal to m. So, the auxiliary equation will become m square minus 4m plus 4 equal to 0. That is m minus 2 the whole square equal to 0. So, m equal to 2 twice. So, the roots are real and equal. In that case, the complementary function is given by a plus bx e power mx. So, a plus bx e power 2x. So, this is the complementary function. Next, for finding the particular integral, here the right hand side is of the form what? X cube into e power 2x. Now, see, in the complementary function, this e power 2x is appearing, no? It is both in the left hand side as well as in the complementary function. But in the, both in the right hand side and in the complementary function. But in the right hand side, it is not appearing alone. If e power 2x is alone, then I have given the table values, but it is not appearing alone. It is appearing along with x power 3. So, what you have to do is, here it is power 3, no? Now, you see, here this factor is of power 2. So, power 3 plus 2 equal to what? 5. So, x power 5 e power 2x you have to include. So, e power 2x is appearing in the right hand side and also in the complementary function. But on the right hand side, it is appearing along with x cube. The corresponding factor in f of d is of degree 2. I am not mentioning this 2. Okay, this may be any number. But this power, no, look at this power. This is of degree 2. So, trial solution must include x power 3 plus 2 e power 2x. What is that? X power 5 e power 2x. I hope you understand this part. Okay, right. So, what is the trial solution? How will you write? Y star is equal to a1. Write this term first. X power 5 e power 2x. Okay. So, you have to descend the powers, because while differentiating this x power 5, what will you get? X power 4, x power 3, x power 2, no? So, write all the values. So, x power 4 e power 2x, x power 3 e power 2x, x square e power 2x. Plus x term and constant term will come, but no need to write them because they appear in the complementary function itself. Here x e power 2x is there and constant into e power 2x are there, no? So, no need to repeat it here. Okay, even if you write it here, that doesn't matter, but you will have some more lengthy calculation. Again, they will become 0 only. Okay, so you write up to x square e power 2x, because the x term and constant term are already appearing in the complementary function. So, I am stopping with this one. This is my y star, trial solution. So for my simplicity, I am just taking this e power 2x outside. So e power 2x into a1 x power 5 plus a2 x power 4 a3 x cube plus a4 x square. Find first derivative and second derivative and substitute. Okay, find the first and second derivative. I am skipping the parts. Okay, find the first and second derivatives. They are too lengthy, so I am skipping them here. Find the values and substitute it in the given equation. Okay, while substituting in the given equation, you have to write it like powers of x power 5 plus x power 4 x cube plus x square plus x. Then only you can equate the coefficients on left and right hand side. Okay. After that, equate the coefficients of a constant term, x square, x cube, x power 4, x power 5, etc. Finally, I am getting what? A1 equal to 1 by 20. All other coefficients are equal to 0. So, the trial solution is y star equal to 1 by 20 x power 5 e power 2x. And the general solution is complementary function plus particular integral. So, y equal to a plus bx e power 2x plus 1 by 20 x power 5 e power 2x. That's all. Thank you.